as a data set or a data becomes the backbone of GIS, coordinate system also becomes or is the backbone of a data. Without the coordinate system, your data is nothing. I remember trying visualizing or I captured the data, trying to visualize it, and my data was in the sea. Meanwhile, I've not been to the sea. That issue has to do with coordinate system. So there is no way you can visualize a data in the GIS world without a coordinate system. Yeah, I know you'll be like, but I can visualize the data and later on the system will tell me that it does not have any spatial reference system. Sometimes when you try to insert a big map which will serve as a reference, you could see that your data is somewhere and the location you are trying to visualize is also somewhere. To prevent all this issue, you have to take coordinate system into consideration whenever you are capturing a geographic data. So therefore, geographic data is nothing without coordinate system. What is a coordinate system? Coordinate system, they are just spatial references that help us to visualize a geographic entity. And we all know that a spatial entity or a geographic entity, they are the real world things that can be represented in the GIS world. So the fact that you are able to visualize your house in the GIS world, there is something that is helping you to do that visualization. And that gentleman behind the visualization is a coordinate system. Let's think of two pencils as an example. You have two sets of pencils, but then you want to join those pencils together. Personally, I'll choose to use, let's say, super glue. Someone can also use a rubber band. Other person can try using a thread. That thread becomes your coordinate system. That rubber band you are using to join the pencils together becomes your coordinate system. So the gentleman that will help you to tie your house to the GIS software is the coordinate system. And this coordinate system is in two folds. We have the geographic coordinate system, we have the projected coordinate system. And it's been advised that whenever you are working in the GIS world, we only make use of projected coordinate system. Why are we only using just the projected coordinate system? Fine, we are using projected coordinate system due to the issue of measurement. Geographic coordinate system is in degrees and those longitude and latitude, but then projected coordinate system will give you a measurement in meters, square kilometers. So the reason why we prefer projected coordinate system over the geographic coordinate system has to do with the issue of measurement. So spatial reference system. I said earlier that geographic coordinate system are spatial reference systems that assist in the representation of geographic entity. What is a spatial reference system? A spatial reference system are a set of conventions and mathematical models used to define the position either in space or on the earth surface. So you see that gentleman that will help you determine the position of your house in space automatically become a spatial reference, and that spatial reference is basically a coordinate system. There are two types of coordinate system, as said earlier, the geographic coordinate system and the projected coordinate system. A geographic coordinate system uses a three-dimensional spherical surface to define location on the earth. So a geographic coordinate system usually take into consideration the spherical shape of the earth. We all know that the earth is spherical. You get it? There is no way the earth is flat. But then the GIS software is trying to cheat, try to convert that spherical shape of the earth into a flat surface. And before you can convert that spherical shape to the flat surface, you need a projected coordinate system. And we are all aware that our computer hardware is a flat surface. And before we can do that, as in transferring the spherical nature of the earth onto the software, we need a projected coordinate system. So a geographic coordinate system includes an angular unit of measurement. You get it, as in degrees and others, angular units of measurement. There is no way if I ask you to measure the distance from your house to the nearby road, you tell me it's 20 degrees. You either say 30 meters, 30 centimeters. So the difference here is angular measurement or angular unit of measurement versus linear unit of measurement. So you see, in a geographic coordinate system, a point is referenced by its longitude and latitude values, which are often measured in degrees. And we are not interested in degrees. Whenever you are in the process of measuring something, or in the GIS world, whenever you are measuring something, which is a distance, you have nothing to do with degrees. We always deal with linear units of measurement. The geographic coordinate system, they are mostly used, or they are the most widely used global coordinate system, and it contains longitude and latitude. And you all know what longitude and latitude are for. So whenever you get a data set, mostly they are in geographic coordinate system, in a sense that the person trying to create a data set is taking into consideration the entire surface of the world. So you as a GIS analyst, it is your job to convert that geographic coordinate system to a projected coordinate system. Then why geographic coordinate system cannot be used for distance measurement? Because of the issue of longitude and latitude. And as said earlier, they are usually measured in angular units, which is in degrees. We are not interested in degrees. In GIS, whenever we are dealing with distance, we are interested in linear units, as in millimeters, centimeters. That is it. So projected coordinate system. Whenever you hear projected coordinate system, your mind should take you to map projection. What is map projection? Map projection is a transformation of a curved surface or the curved earth surface to a flat map. You see, to looking at this is the entire world. So this smaller globe here is the entire world, which is a geographic coordinate system. But then we, using the GIS software, which is a flat surface, we are trying to convert this spherical shape to set of it into a flat surface. We need to divide it. You could see that we have certain zones, and those zones are what? Universal transverse Mercator, as in here. So you could see that they always say that Nigeria is ahead of Ghana in Wana, and that Wana is what? 15 degrees. So the process of it transferring the nature of the earth into a flat surface is what? Map projection. And in the process of doing that, we are dividing the earth in smaller zones. And those zones are called what? UTM zones, as in Universal Transverse Mercator. So each zone is given a number. You get it? And those numbers becomes the coordinate system, as in the projected coordinate system. So projected coordinate system is used to locate objects on a flat surface. You get it? We always use projected coordinate system to represent an object in a flat surface, and we all know that either you are using a laptop, either you are using a desktop, it's what? A flat surface. Every GIS software is what? A flat surface. So the process of we doing that, we are projecting what? The map. So we are transferring the curvature of the earth, as in the spherical nature of the earth, into what? A flat surface. And we doing that, we thereby what? Divide the earth into zones. and those zones becomes UTM, and that UTM contains some numbers. Those numbers become the coordinate system. And those numbers, as you can see, you see that there is a red line dividing it, as in the northern hemisphere and the southern hemisphere. You get it? So you could see that the coordinate system of Ghana is usually based in what? The northern hemisphere. Why Ghana can be located within the northern region, or not as in the north, or as in the northern hemisphere, taking the entire world into consideration. You get it? To the coordinate system for Ghana. Usually, Ghana contain about two coordinate systems. So Ghana falls within the zone 30-31. Ghana falls within the zone 30-31. The zone 31 is usually meant for the people around the Tema area, but the most common one is the zone 30. But Ghana falls within the 30-31, taking the Greenwich Meridian into consideration. So the people in Tema area, you see that Tema area where the Greenwich Meridian passes, those people make use of the zone 31. But then the common one here is what? Zone 30. So provided you are using ArcMap, ArcGIS, you usually go with WGS 1984 UTN zone 30 north. That is the projected coordinate system for Ghana. But then if you are dealing with GeoJSON, we have that coordinate system there. But then there are some figures that you need to keep it in your mind. Whether you are lost, whether you are asleep and someone just tap you, hello, give me the coordinate system for Ghana. Provided you are working in GeoJSON, you have to keep these figures. 32,630. So that's the coordinate system for Ghana. The 32,630. If you are working in GeoJSON, you have to keep this 32,630 in your mind. That is the projected coordinate system for Ghana. But if I'm working in ArcGIS Pro or ArcMap, the coordinate system becomes WGS 1984 UTN zone 30 north. But then if I move to GeoJSON, I have to keep these figures in my mind. Zone 32,630. When you get to the QGIS environment, they usually take into consideration three coordinate systems. We have the Accra Ghana grid, then the meter grid as well. When we dive into the practical aspect, you see the effect of each projection on the map. You can see that when you are using the Ghana meter grid, you see that it usually places its concentration on just the boundary of Ghana. But when you are dealing with the national grid, you see that it sometimes gives room for other regions sharing boundary with Ghana. So that is the effect of the map projection. And each map projection has effects on the data you are working with. So those effects are termed as map distortion. Sometimes you can try to project your geographic data, and you see that after projecting, the data is somewhere in the sea. It is the issue of what map projection or map distortion. Sometimes maybe the coordinate system you are trying to configure to the data set does not match. Assuming you are working in Ghana, then you are projecting your data using a coordinate system of 32, let's say south, so WGS 1984 zone 32 south. There is no way the data set will fall in Ghana. It will fall at that particular zone that uses the specific coordinate system that you are using. But then, assuming you are in Ghana and during your projection, you set your coordinate system to WGS 1984 UTN zone 30, it will 30 north. It will automatically place your data set in Ghana, then straight to the location where you are. And if you are working in QGIS, just keep these figures in mind. 32,630. It's very, very helpful, because you might get to a point whereby when you are using the WGS 1984 UTN zone 30 north, you see that if you are working in QGIS, you see that your map is somewhere. I have no idea why it usually happens. So the QGIS people usually use 32,630 or Ghana meter grade or Ghana national grade. That is it. We have the Accra meter grade, which is the Ghana meter grade. So this is the coordinate system for Ghana. Provided you are working on ArcMap or ArcGIS with WGS 1984 UTN zone 30 north. You get it. And the projection is transverse Mercator. Then we have the false eastern, the false northern, the central meridian, the latitude of origin, then the unit of measurement. So the unit of measurement is what? It's in meters. So you see, it is a projected coordinate system. It does not give us in degrees, but in meters, as in linear units. So assuming you are using this coordinate system for measurements, there is no way you tell me the distance from your house to your neighbor is 30 degrees. You will be like, oh, okay, so the distance from my house to the nearby road is 20 centimeters, 30 kilometers. That is it. Then you are good to go. So always, when you are working in the GIS environment, you make use of projected coordinate system. If you are working in Ghana, you keep this coordinate system in your mind. If you are working in, let's say, GeoJSON, you keep the 32630 in your mind as well. Then you have some practical rules, in every institution, in everything you do, there are rules. In our education communities, we have rules. Even with your mobile phone, you have rules. When you buy a new mobile phone, there is a rule associated with it that you need to charge your battery fully before you start using the mobile phone. What happens if you don't charge it? It's either your battery will get spoiled or something. So there are some rules in the practical aspect of GIS. What are those rules? Always check your coordinate system when uploading a GIS data. You cannot go straight forward and go and check your no. You do that after uploading your data onto the working environment. So whenever you get a data, you upload the data to the environment. Make sure you check the coordinate system. Transform data to consistent system before analysis. As in, you should make sure that the data set you are working with, they contain, or the coordinate system they are using, they have the same coordinate system. There shouldn't be a case whereby you are using, let's say you have a data set which is meant for all the regions in Ghana. You also have a data set which is meant for all the districts in Ghana. And then your regional boundary is bearing a projected coordinate system, which is WGS 1984 UTS of 30 months. Then your district boundary is bearing a different coordinate system, which is WGS 84, which is what a geographic coordinate system. It doesn't work like that. Once you upload a data set bearing two different kinds of coordinate system, the software will automatically alert you that the data set you are bringing, there is a conflict of interest here. One is bearing a projected coordinate system, and the other is bearing a geographic coordinate system. There is the issue of data exploration, and this is one of the basic rules that you should keep it in your head. Data exploration. What is data exploration? Data exploration is basically about you trying to explore your data. You want to know what your data is about. If I give you a shapefile, which is Ghana.shp, fair enough, you know that Ghana, it means that something in Ghana. You could be like, okay, this means that the boundaries of Ghana. Meanwhile, maybe it's a data set that contains HIV patients or anything at all. You are not aware. So what you do is you explore the data. How do you explore the data? In your process of exploring the data, you make use of attribute table. What are attribute table? Attribute table are what? The descriptive characteristics of the data set you have. So whenever you get a data set, you first of all check your coordinate system. You make sure there is a consistency in the coordinate systems. Then you make sure that you explore your data. Data exploration is very, very useful because when you explore your data, you know that, okay, so I have this field and that field. So when I join these two together, I'll get this. You being a GIS specialist or a GIS analyst, there is no way you won't explore your data set, then boom, automatically you start an analysis. You definitely run into a problem whereby you just have to come back to come and check, okay, so what data set and what data set do I have in this particular data? So once you get your data set, don't forget to check your coordinate system. Don't forget to explore your data. Another rule is always make sure that your working environment or your software is in projected coordinate system. So I always advise anyone I come in contact with, as far as geographic analysis or as far as GIS is concerned, I always tell them that whenever you launch your software, the first thing you are supposed to do is not to go and connect your folder, bring data. No, whenever you launch your software, the first thing as a GIS specialist or a GIS analyst you need to do is to what? Check the coordinate system of your software. You should always check the coordinate system of your software. When it's in geographic, you just project into what? A projected coordinate system. Because in the GIS world, we always work in what? Projected coordinate system. Well, I think this is the end of the theory. So, as I said earlier, in everything you do, you need the fundamentals. As GIS is concerned, you always need the fundamentals. The fundamentals is very, very important. And within the fundamentals, it doesn't mean go and read everything, go and read every book. No. You need some definition, the application, the importance, the practical rules, the coordinate system, the data sets, then you are good to go. You can start with your analysis. So as I said earlier, geographic system or GIS is a geographic system that helps us to capture, analyze, visualize data. We talked about the data models used in GIS as a vector, raster, and thing data. I know most of us here, we have not come in contact with this thing data. I'll try and get something maybe in the practical aspects. I'll just show you how the thing data look like. But mostly, you usually get a thing data when you are working with LiDAR. Then we also talk about the coordinate system. And I said that the coordinate system are just reference system that help us to visualize a geographic entity in the GIS world. And we know that geographic entity are the real world things that we can represent in our GIS world. So that is it. And we also talk about the coordinate system being um, projected and geographic. And we also have some tools in GIS, and those tools are the softwares. So we have ArcMap, ArcPro, QGIS, WebGIS, as in ArcGIS Online. We have ADAS Imagine. We have, there are so many of them. I don't have most of them in often. We have so many of them. We have tools for that helps in both remote sensing and GIS as well. You get it? And I said earlier that remote sensing is just you trying to get information or you trying to access the information of something without being in contact with the thing. Assuming you are here in Ghana and you are what? Trying to visualize the river in, let's say, the river Mississippi. You are here calculating the depth of river Mississippi, visualizing river Mississippi, running land cover analysis around river Mississippi. You are not there, but you are accessing what information. The process of you doing that is what you call what remote sensing. So I think this will be the end of the theory. And the next thing we'll be doing is we'll be visualizing the QGIS interface. Then we'll call it a day. So I would like to pause here. So this is my QGIS software. I'm using the version 4.0. Yeah, but what I gave out was 3.8. But it's the same thing. There is nothing different. I did that because of the size. The one I shared with you was about it's 500 and something megabytes, but this is about 1.3 gigabytes. So after the installation of the software, you see that there will be a folder created for you on your desktop. So this is my folder, QGIS 4.0, but yours will be QGIS 3.4, 4.9. So you just open the software or open the. So let's continue. So I'm assuming that this is our folder. You double click on it to open. Then within the folder, we have different kinds of QGIS software. But then we are making use of QGIS desktop. Then your version will be there. Mine is 4.0. I'll just double click on it. So depending on the speed of your PC, this is my interface. But your interface will be different from mine. But it is the same thing, same version. Yeah. QGIS is not like ArcMap or ArcPro, whereby if you have 3.6, it's different from, let's say, let's continue. So this is my interface. Once you open QGIS, this is what you get. And sometimes you might not be getting this. This is the reason behind that particular issue. I have used mine for a project. Assuming you have not used yours for anything, you will just get, is it a template or yeah, something like this. You get a blank space, then you get some information about the QGIS itself. So you see here we have latest news, and it's not important. You just close it. Or if you are not seeing this, you just click on the blank, then automatically to open a new project for you. So as I said earlier, this interface here, it's the entire world. This small white interface that you are seeing, it is the entire world which is being visualized as a flat surface. Which is being visualized as a flat surface. And as ArcMap and ArcPro uses two boxes, QGIS also has its own two boxes. And QGIS uses plugins. Plugins are additional tools that you can install to run any analysis. We have people that are developers who day in and day out, they try to develop a QGIS plugin. So those plugins are uploaded online, and you being the user, you can go online, you download that plugin, then you use it. So I'm assuming that this is our first time and we don't have anything. So I think when you open a new QGIS interface, you don't have this. So you have something like this. So let's start with the exploration of the interface. First of all, I said that this is our working environment. And I said earlier that whenever you launch your software, you have to check the coordinate system of your working environment. So this is our working environment, which is the entire world. If you don't believe and you want to confirm, we have the menu bar here. The menu bar is where we have the project, edit, view, layer, settings, among others. Then we have the project tags bar or the status bar. The status bar is where we have the coordinates, the scale, the magnifier, the rotation, and the coordinate system. So you see where we have the coordinates. You see where we have the coordinate, we have some values there. Put your cursor in there, then you click to select. Once you click to select, you see that automatically you see some bouncing dash over there. Click on Control plus A, which means you are selecting everything. Then type world, WORLD, then hit enter. Tell me what you see. This is the entire world which is being visualized as a flat surface. You get it? So I said earlier that surface. So I'm guessing we don't doubt now. Okay. So whenever you open the software, we have some bars and tools and panels that you need to activate them. Empty space at zero. Yeah, just put your cursor there, then you click on it. You right click on it. So once you put your cursor on it, then you right click. You see we have browser panel, advanced digitizing. So you see the boxes that has been checked on mine. Make sure you check everything on yours as well. So you can check the browser panel, provided the browser is not there. You can check the browser panel, the layer panel, then this portion of the panels, as on your right hand, you check the help toolbar if it hasn't been checked, but I'm guessing it will be checked or something like that. If it hasn't been checked, make sure you check it. Then on your toolbars, you make sure that the attribute toolbar has been checked, the data source manager has been checked, which is very important. The data visualization toolbar, the density analysis toolbar, the digitizing toolbar. I'm assuming you might not have the density analysis toolbar because it's a plugin. So you check the available ones over there. Once you are done, on the menu bar, you see something like processing, which contain all the toolboxes in QGIS. So you just click on the processing, then you select toolbox. So the toolbox are just like a carpenter toolbox. You see, it contains all the tools that he uses during his work. So this toolbox contain all the various toolboxes that is associated with QGIS. You just click on it. Automatically, you have your toolboxes here. So just like ArcMap and ArcGIS Pro, the geoprocessing thing, it's here as processing toolbox. So whenever you are trying to work on something, you need a specific tool. You just make use of the search. You type in that tool, you hit enter, automatically you get your tool. Okay. So once we are done with that, you will do something called folder connection. You know, one of the things, okay, so let's deal with the rules we talk about. We need to check the coordinate system of our working environment. You get it? And on your right side, and just near the render, you see we have the coordinate system over there. This one, where my cursor is. I want you to do is, you see there is a coordinate system there, as in EPSJ 4326. That is a geographic coordinate system for the entire world. So if you put your cursor on it, you see WGS 84, which is a geographic coordinate system. And we said that in the geographic world, whenever you are working, you need to work in projected coordinate system. We've launched our software. The next thing you are supposed to do is to project our working environment. How do we project our working environment? We go back to where the coordinate system is. Then we click on it. So this is where the coordinate system is. Then you click on it. Once you click on it, you see automatically this will appear. So that's the project properties, the coordinate reference system. So once we have this, you see we have the projected coordinate reference system. You see what the software is telling us? Projected coordinate reference system. And we have no CRS, as in no coordinate reference system, or the coordinate reference system that is being used here is what? Unknown. It is not a projected coordinate system, so it's what? It's unknown. This coordinate system here is a geographic coordinate system. And as said earlier, in GIS, we always work in projected coordinate system. So you see that in your predefined coordinate system, there are several coordinate systems over there. We have the WGS 84, which is EPSD 4326. And I said that in the QGIS world, the coordinate system for QGIS, as Ghana is concerned, is what? 32630. So for us to project our working environment, we just go to where we have the filter. This is the filter. See, this is the filter. I have used mine for work before. That is why I'm having the coordinate system for Ghana here. So you see, we have EPS 32630, which is the same as WGS 1984, UTS in 30 knots. You get it? But you, since you've not used yours for a work, you just go to where the filter is. Then you type in 32630, 32630. Once you type 32630 under predefined coordinate reference system, which is the CRS. So the CRS you are seeing there is what? Coordinate reference system. Automatically, you see that your coordinate reference system will jump towards projected. So you see projected, and under projected UTM, Universal Transverse Mercator, which is WGS 1984, UTS do not 30 knots. And the ID is 32630. So you always keep the 32630 in your head. Whenever you are trying to work in Ghana, then you want to project your working environment, you will click on where the coordinates or where the EPS is, that is your coordinate system. And then under filter, this is filter. Under the filter, you just type in 32630. Once you type in the 32630, the coordinate system will automatically appear. So that is it. You just click on it to select, then you click on apply. Once you click on apply, then you click on OK. Tell me what you see. You see what I was talking about concerning the map distortion. So at first, we visualize the entire world, as in the entire globe, on a flat surface, which is the QGIS software. But right now, we are projecting our working environment, in a sense that we are telling the software that we don't want to work in the entire world. We want to work in a specific UTN zone, which is UTN zone what? 30 north or 32 630. Where is 32 630 located? Ghana. So definitely there is no way this will look like how it was looking earlier. You see, earlier everything was showing, but right now you're asking the software that I don't want to view everything. I just want you to send me straight to what? UTN zone, UTN zone 30 knots. You get it? That is the 32 630. So this is what? Effect of map projection, because this is automatically is the entire globe and we've projected on a flat surface. So this is the effect of the coordinate system we are using. When you scroll your map to Ghana, you see that this is the Ghana map, or this is the boundary of Ghana. It has done what? Nothing, or there is no effect on it, because this is the zone that we projected our working environment to do is install some plugins. As I said earlier, that plugins are additional toolboxes or additional tools that QGIS uses. If you can see my menu bar, I have something like HCM GIS. This usually contains some base maps. You get it? So assuming I want to add a base map, and we all know that base map are just reference mapping. So if I want to add a base map, this is what I'll get in a base map. But then, since or if you are new to the software, you might not be having it. So we need to install that plugin. For us to do that, on the menu bar, you see we have just after settings, we have plugins. You click on the plugins, then from the options, select manage and install plugins. So you click on it. If you don't have internet, it will show up. It will come like this, all right, but you won't be able to do any installation. QGIS can work without internet, but if you want to install a plugin, you need internet. So once you click on the manage and install plugins, in the search, just type HC, HCMGIS, this. So once you type it, you click on install, then it will automatically install, then you are good to go. Then another plugin that we'll be installing is Quick OSM. That is it. The Quick OSM, then OSM itself. So once you install the Quick OSM, it will automatically add OpenStreet to it. You get it. So OSM. You just come back to the search and type Quick OSM. So once you type Quick OSM, it will appear. Then you click on install. Mine has been installed already, so there is no need for me. Or I can just click reinstall. You see, it's downloading. The last plugin for the day is multi-buffer. Yeah, it's multi-buffering. That particular plugin is not compatible with the 4.0. So tomorrow I'll be using that of your version. Then I automatically get the multi-buffering. So multi-buffer, then you install it, then you are good to go. Once you are done with the installation, click on close. So the last thing we'll be doing is to bring our folder that contains the data set to the environment. So what you are doing is we want to link our data set together with the software, because we have our software in a different location and we have our data set in a different folder as well. So for us to do that, we already have the browser. I'm assuming everyone has the browser. So within the browser, you see we have something like favorite. Select the favorite, then right click on it. Once you right click on it, select add a directory. Just click on it to add a directory. So once you click on add a directory, the next thing you are supposed to do is to navigate to where you save your data or where your folder is. Then you link it to the software. So tomorrow when you come, there is no need for you to be doing the entire thing again. You just go into that folder, then you get your data, then you are good to go. One funny thing about QGIS is that even though you have not extracted the data set, but you can still bring it to the working environment. I have mine under QGIS tutorials. So I'll go into QGIS tutorial, then material, then I'll select data. So select folder. So once you select it, you see that automatically that folder has been added to your favorite. This is the folder I added. Yeah, this. So this is it. QGIS tutorials, materials, then data. So if you click on the drop down arrow, this folder we brought. I'm assuming that we've been able to bring our data as well, or the folder. So once we have our data, that is it. So right now our screen or our working environment has been set for us to work on. So tomorrow, God willing, we'll be going into the practicals. There will be nothing like theory, it will be just practicals. So so that we can call it a day. You don't have to bring your data, just look at what I'm trying to do. So he was asking, how can we visualize the digital numbers? So that is what I'm trying to do. As I said earlier, that raster data set is made up of pixels, and behind those pixels, there are some digital numbers. So I wanted to show you those digital numbers. Yeah, so this is a raster data set, which is this is somewhere UCC, so University of Cape Coast. And I said that you see, this is a continuous interface. And I said that this interface you are looking at is in a way a series of pixels, and those pixels contain some values behind them. This is not an elevation data, but then it is a raster data set, right? So if I zoom in, you see that it's made up of series of boxes. You see that, can you see those boxes? You see, it's made up of boxes. And I said behind those boxes are numbers, and those numbers are digital numbers. Someone asked a question that can we visualize it? And I said yes. You see, just beneath your menu bar, you have this is it map navigation toolbar. Then we have the attribute toolbar. You see this eye with the mouse pointer on it, this one. identify features or identification to click on it. Once you click on it, you see that automatically your cursor will change. So this is a pixel, and I want to visualize the digital number behind that pixel. And mind you, this is an RGB image. It's more like a drone image, but then I download it from GeoJSON. I use this software to download it. So it's more like a drone image, yes, but then it's just from GeoJSON. And this is a tree. This is a tree. So I want to identify the digital number behind that tree. I just click on this. So once I click on it, you see, I have my values here. Band one, the value of band one within this pixel is what? 61. You get it? But behind that tree over here. So you see, it is not just a tree, but it's a digital number which has been processed and being visualized as a continuous interface. So the band one digital number is what? 61, and band two is 61 as well. But then band three is 49. So assuming it's an elevation data, you see that once you click on it, the value will appear. So that is how you can visualize the digital number of a raster dataset in GeoJSON. You can do the same thing in ArcMap, ArcPro, NV, anything at all. So that's it. So we can now confirm that indeed raster dataset contains digital numbers and not just an interface. This will be the end for today's session. So for tomorrow, 9:30 sharp, we'll be starting. There will be nothing like theory. It will be just pure practical. So get yourself ready. And